Hello, everyone. Can you hear my voice?
Yes, we can hear.
I'm sorry for the delay. We had a problem with the Zoom link. I think they are using a new link, but they inform me lately. Today we have 6 presentation. The first author is Emre Bülbül, Dr. Bülbül. I think he is not in the room, right? Dr. Bülbül, can you hear me? Now we can wait him, and the second one is Hasan, Dr. Hasan İlhan.
Yes.
If you are ready, we can start with you.
Yeah, I'm ready.
Dr. Hasan İlhan will present us bacteriophage-based lateral flow immunoassay system for detection of Salmonella enteritidis. I'm sorry if I have
no problem.
in the pronunciation. It's a different topic. All right, we are listening to you, and you can share your screen.
So right now I got it, your sharing system. So is available or not?
I will check. I make you host. All right, now you are the host. And
so I click the share screen.
yeah, I can see your presentation.
And then I click my PowerPoint. Your screen sharing.
Yeah, you should share the screen at the bottom of the screen. I can see your page, no problem.
You see?
Just press F5 and you can start
F5.
your presentation.
I think this is, Mac. I don't know how to do, but maybe let me open all page. You can see that.
Now you down your Zoom screen, turn back to your main computer screen, open your presentation and go. Now it's okay.
That's okay?
I can see it's in full screen. Yes, it's okay.
Yeah, right. It's okay, right?
Yes, you can start.
Okay, let me start. Actually, special thanks for your committee, because before I started my presentation, and today everybody know that we have some coronavirus problem. That's why we cannot get see each other, and then it's not possible see these diseases. So I believe that as soon as possible we can get the normal life, and then we can see each other, and then face to face. And then we can do our discussion, like, brainstorming and feedback together. So I hope, as soon as possible, we can get some, solution about this problem. And then again, we can see the, all things again. And also I said, my deeply condolence of all, pass away because of these viruses. So today my topic is bacteriophage-based lateral immunoassay system for detection of Salmonella enteritidis. Actually, today, like, bacteriophage also is, virus, look like, corona, but this is, just, determine the bacteria with using the bacteriophage systems. And is like, lateral flow immunoassay, actually, you can heard that, like, pregnant test today, so many people is not going to hospital directly, just like, they have paper-based detection of pregnant test, and then they see they are pregnant or not. They can decide if, like, tests show that positive, supposed to be going to hospital to do your, his, like, things for another, growing things. So that's why we improving the, bacteriophage system. Why we have been using bacteriophage? Because today there are a lot of things with using, like, biosensor systems. One of them, like, antibody system, aptamer system, like, DNA systems, but little is expensive if you compare the bacteriophage. Today in the lab, we have been, producing, like, bacteriophage systems to easy, and then we can get more things. So that's why, we, investigate the bacteriophage systems. So let's see first, what is the bacteria? And then if you see in the bottom, like, this is, we synthesize, iron nanoparticles. The iron particle we functionate on the surface to capture the bacteria. This is Salmonella enteritidis. So what is the, this one? First of all, they are single cell and prokaryotic creatures. And today there are everywhere there is no option. Absolutely, we can see bacteria. And also, like, if you think about what is the, like, size, this size, like, looks like 0.45 and 10 micrometer. And Salmonella enteritidis looks like 4 and 6, micrometer. And then that's why we, optimize our, materials such as iron nanoparticles and gold nanoparticles to capture the, like, bacteria. And also, like, this is just only organelle is available ribosome, and RNA and cell membrane is also, like, basic thing on bacteria. And also in the right side, you will see that some, like, gram positive and negative bacteria, and all of things, like, you can see, like, some, bacteria things. And one of them pink color, we call that gram negative. One of them is purple, we can call as gram positive. And also there are a lot of things, if you, see that, like, according to oxygen requirement, aerobe, anaerobe, and facultative and microphilic bacteria. And also it's very important, their shapes. Some of them spherical, some of them rod shaped, some of them spiral, and some of them virgin. In, like, bacteria, like, rod shape, and then you can see, like, transmission electron microscopy result, and then this, like, 3 micrometer bacteria size. So let's say another slide. Yeah, so we have been using instruments, surface enhanced Raman spectroscopy. So you can see that picture shows that basically how to work this system. Surface enhanced Raman spectroscopy, actually, if you compare the Raman spectroscopy, what is Raman? Raman is, like, quantitative technique, and where scattered light is used to measure variational energy modes of sample. So first of all, they got it, like, this novelty called as Indian physics Raman. Raman also, together with his partner, like, Krishna, and then they got Nobel Prize in 1928 to gather the Raman spectroscopy. Raman spectroscopy actually provide both chemical and structural information, as well as the identification substances through their characteristic Raman fingerprint. Raman spectroscopy extracts this information through the detection of Raman scattering from sample. Actually, we have been using surface enhanced Raman spectroscopy. Surface enhanced Raman spectroscopy actually more, accuracy. And then in the articles just say 10 over 14, like, more, accurate, lower concentration. So that's why, recently people has been using, surface enhanced Raman spectroscopy because of you can get lower concentration detection. So let's explain a little how to work. If you see that, like, bottom side and right side, scattered, by, some target, oscillating electromagnetic field photon induces a polarization of molecular electron cloud. So we call it as dipole moment, which leaves the molecule in a higher energy state. With the energy of photon transferred to molecule, this can be considered as the formation of very short-lived complex between photon and molecule. So if you look at our system, the energy levels, if laser energy wave, if you equal each other the laser, we call that Rayleigh. If, like, changes bigger or lower, we call that stock and anti-stock Raman scattering. And then we have been using Raman scattering, and then we can understand what's the molecular structure of, like, our analyte. So this is paper-based system. Today, if you look at, like, upper side, this is paper-based system. Paper-based system basically constitute of 3 parts. One of them is test line. This is test line. this is control line, and this is conjugation pad and sample pad. And the flow right on the nitrocellulose membrane. At the end of that, the absorbent pad collected everything. Let me explain briefly. First, you have to sample on the sample pad, such as urine, such as blood, such as something like that. And then you add the sample pad, conjugation pad generally contain gold nanoparticles. We functionalize gold nanoparticle surface like an antibody or bacteriophage and DNA or aptamer system, depends on you. And then we, in the system, first, we optimize functionalization of the gold nanoparticles antibody systems. And then your samples, such as including bacteria conjugate with gold nanoparticles, and then flow on the nitrocellulose membrane. And then first test line, we drive on the antibody. And then another things, bacteria, if capture the antibody with gold nanoparticles, absolutely we will see that on the test line some color because of the gold nanoparticles. If you see that any color test line and then control line, such as think about this is pregnant test, this means you are pregnant. If you cannot see any line on the test line, this first line, and then if you see any line on the control line, that means you are not pregnant, system is working. But if you are not see anything, any line, test line and control line, that means your system, your paper base doesn't work. So that's why we improved some systems. One of them antibody system, one of the bacteriophage. Today we have more experience for antibody systems. So that's why today we improve bacteriophage system. Bacteriophage system, if you see that on the left side, antibody captured bacteria, and the upper side got nanoparticles and also contain antibody captured bacteria. And then test time we have been using like Raman label to see that depends on concentration to get a quantitative analysis. And also the right side, we alternative method for antibody systems. So let's see what's gonna be happen. First, we synthesize gold nanoparticle materials. So we synthesize two different kind of gold nanoparticles. One of them benzyl cation, base gold nanoparticles. In the left side, you will see that transmission electron microscopy, and then it's too clear, and then monodisperse, and then I think the size of the gold nanoparticle actually 20 nanometer. And then if you look at the UV spectrum, 525 nanometer, you can see the spectrum, and then this is gold, spectrum. Right side, depends on straight base gold nanoparticles transmission electron microscope image, and also UV spectrum also confirm our synthesized is correctly, and then this synthesized thermal synthesized method. So let me explain a little bacteriophage. So this is everybody, wonder what's, corona, what's the virus? So this is virus, and then there is contained some heat, and then this is, contained in this part nucleic acid. And then there is some part, sheet and spike and tail fiber. This tail fiber directly, capture the, annelid on the surface. And then if no death, such as salmonella and this, virus, related with salmonella bacteriophage, and then this, tail fiber know that the host, and then trying to, growing up more and more with logarithmic, things. So I got some, paper. This paper explain how this system works. So this first one, landing parts, this in the first part, chemically secreted, prevent the bacterium from expressing its own genes and own proteins. This process just only a few seconds. After a moment of attachment, and then virus invades bacteria. And then second one, pining. This is just 5 minutes. Then virus RNA, if available DNA, begins to produce enzyme. And then that system allow the DNA replicated or RNA replicated. And then the virus can use the bacteria's DNA for the system. And then 10 minutes after infection, DNA self-replication process begins. This is like you can see tail contraction and penetration. And then at the 12th minute, proteins produced from DNA come together and begin to produce new copy of viruses. And then after 30 minutes, there are a lot of copy of the virus have formed inside of bacteria. So that's why I think about corona, just only 30 minutes, that's enough to, if you find the host, 30 minutes, that's enough to get that there are a lot of copy of the virus. So let's see that today, how is it, this application have to work. So first, I explained first bacteria infection, and then after bacteria infection, cell lysis, and then after cell lysis, how to determine of this, system. One of them, we have been using advanced materials to capture target, such as you can use nanoparticles, quantum dot, and then functionalize on the surface, and then target, capture the target and then detection of separation. Or you can improve sensing layers. And then such as I put some, gold layers, and then you modify these layers to capture the, bacteriophage system to your analyte. And then you can improve some biosensor system also. So let's say our system have the word bacteriophage vector detection methods. So this is our first result. So on the right side, you can see we synthesize, metal organic frameworks, magnet nanoparticles. These nanoparticles directly contain carboxylated groups. So that's why we don't need to functionalize on the surface of iron nanoparticles. So that's why if, this nanoparticle contain carboxylated groups, directly EDC NHS activation to bind your antibody or bacteriophage on the surface of iron nanoparticles. For in the system, I functionalize this iron nanoparticles with bacteriophage. So we put some sample with some tubes, and the iron nanoparticles interact and then capture with bacteria, and then we use magnet collect all of things and then throw it, remove it your samples, and then again you can add buffer, and then just on the iron nanoparticles capture the bacteria. And then we used some label. This label also contain antibody to see that bacteriophage system is working or not. And then we got this sandwich complex, such as all articles they call this sandwich complex because of bacteria, iron nanoparticles, gold nanoparticles. They call this sandwich complex. And then you can see that we try to 10/1 colony forming units per milliliter, the bacteria concentration to 10/6. This at the bottom of side, you can see the blank. Blank doesn't contain any bacteria. And then we got the calibration curve system is work. And then we got the, transmit electron microscopy result. Iron nanoparticles just functional bacteriophage system, and then capture the bacteria for image, confirm our result is working well. So let's see how is the paper-based lateral flow immunoassay system based on bacteriophage. So let's see. This is, paper-based system. First of all, I showed that image. This is real sample. First, I added my sample, and then it's flowing range. This is flow direction. You can see on the right side, and then bottom side is going to upper side, but I put it like that, and then the lateral flow, and then I add the sample, path to my bacteria, and then conjugate with gold nanoparticles, functionalize antibody or bacteriophage. And then test line contain just only bacteriophage. And bacteriophage capture the bacteria. That's why you can see some test line, and then you can see colorimetric detection because of the gold nanoparticles red. And then this system is work, and then because of the second line is clear, and then you can see blank line doesn't contain anything, and the first time at the end left of side, you can see there is nothing in the first side, but second thing is available. That means blank show that yes, you are right. I cannot capture any bacteria because of there is no any bacteria, but this system working because of the second line. So how about result? So First of all, we have to understand this system directly depends on and is working well properly with bacteriophage. So first, the A, we call that A, just only antibody system. Test line and conjugation pit, just only we modified antibody system with gold nanoparticles and iron nanoparticles. And then we got a calibration curve with different concentration of bacteria, and then we got to see that concentration increase and calibration curve is linear. And then we change, and then second at the middle of the graphic, you will see that test line antibody, conjugation agent, bacteriophage. Again, we got that system is work, and then concentration increase depends on the bacteria concentration, and then you can at the bottom of site we got that calibration curve well, and then R2 value is 0.98. At the end of that, and then we try to get at our target. We can do bacteriophage system directly. And then at the end of that, we functionalize gold nanoparticles, bacteriophage and conjugation phase. Gold nanoparticle also contain bacteriophage. And then system work, and then we got a great calibration curve, system properly grade, and then that's why we decided to do it. Bacteriophage system is working on the lateral flow immunodetection. So this is on the nitrocellulose membrane. The A just say just only bare nitrocellulose membrane. There is no any interaction. Another thing, we added bacteria. Bacteria is flowing the black lateral flow nitrocellulose membrane surface, and then you can see on the scanning electron microscopy. This is like Salmonella enteritis interact with surface of nitrocellular membrane, and also CT also showed that this is like nitrocellular membrane, and then Salmonella interact on the surface of nitrocellular membrane. So these images also confirm this system is work, and then bacteria interact with antibody or bacteriophage, and then we can see that on the nitrocellular membrane surface. So how about application? So we collaborated Hacettepe University Food Chemistry Department. They, give us some, chicken and egg samples, and then we applied this system on the lateral flow immunoassay detection system, and then we got it. This system is working, and then we tried it 10 over 2, 3, 4, 5, or 4. Depends on concentration, we got it in a linear and properly concentration increasing. So if you put some table to explain what's happening, first we added Salmonella enteritis known amount of concentration. So such as added 2, 3, 4 inside of the chicken or egg. And then we got some intensity cells result, and then we use the equation of calibration curve, and then we converted, and then we found that Salmonella, if you put 2, we got 2.18, 3, 2.79, 4, 4.17. And then if you see that, what's the efficiency? Efficiency really and really better. And then we got it 190%, between 90 and 100% result. So that means your system is working well. How about this is egg? How about chicken? Sorry, yeah, this is chicken, and this is egg. Egg also we got it again between 90% and 100% efficiency. So that means if you get any samples, chicken or any such as urine or saliva or something like that, it doesn't matter. We can get it and we can apply our system with different kinds of things. So how about if you use different bacteria, and then this bacteriophage specifically is working Salmonella enteritis or not? So that's why we prefer a Bacillus, E. coli, and Micrococcus. And on the left side, just only antibody and bacteriophage system mixing system. Right side, just only bacteriophage system. Both of things, they say this system specifically selective Salmonella enteritis because fiber system just only know that Salmonella bacteria, if see or any stimulate to see that another bacteria cannot get any many copy of the virus on the surface of that bacteria. So this means our natural paper-based system selectively specific Salmonella enteritis with using surface enhanced Raman spectroscopy. How about, okay, another one just contain, there are kind of bacteria. How about different Salmonella? So that's why we prefer Salmonella temperium. And then we compare again, if you use different Salmonella parts, really and really this system work, Salmonella enteritis. And then we got it like, the same thing, lateral flow immunoassay detection. And then again, specifically see that this system just only know that Salmonella enteritis. And then you can see the result. And then we convert the relative cell signals. And then Salmonella enteritis such as, cell intensity 1000. If you think about the cell's relative signal 100, and then cell's temperium looks like 25 and blank 5 or 10% because of some non-specific interactions. So if you compare different methods, such as bacteriophage system, today I research some kind of things people have been using, such as flow cytometry, colorimetric system, bioluminescence, optical system, polymerase chain reaction system, all of things really and really is working. And then they haven't used Salmonella, and then limit of detection 10 or 1, 2, or something like that. Our result also is very well, 7, a cone-informing unit limit of detection. But it's very important point that this system we can get very fast, such as analysis time half an hour. Actually 22 minutes, just we call that 30 minutes, actually 20 to 23 minutes. But half an hour, we can get it directly quantitative result from the lateral immunoassay detection based off bacteriophage system. So that's why our system is advantageous of the time. Limit of detection also too close. So we think about as a result what's happening. In this study, we synthesize gold nanoparticles. Why? Because gold nanoparticles optically we can change the surface because of some tile group. And then we use some label, Roman label. This Roman label DTMB. DTMB contain the tile groups. Tile group directly bind the gold nanoparticle surface. Another thing just only contain carboxylated groups. Carboxylate group, we can gather EDC and HSA activation, covalent binding to capture the target, DNA, protein, or bacteria. It doesn't matter. It depends on you. And then to see that lateral flow immunoassay detection, the colorimetric, and to see that quantitative calibration curve. So that means if get any samples, we can understand what is the quantitative, and then colorimetric we can see is okay or not, is available or not. So and then the paper-based system optimized, and then we got the limit of detection R2K value is 0.9, and limit of detection looks like the 7, and then we tried the depends on concentration 10/1 and 7, and then we got a good result. In addition, constant formation of distinct lines, tense line by acting on the nitrogen membrane, and then with interacting gold nanoparticles, and then we got it covalently bind on the surface of the membrane, and then short time, actually 30 minutes, and then this is a big advantage also for this system. And also this system show completely specific salmon enteritis. I showed that the validation test, and then we try to do many kind of bacteria things, and then we got a good result. And specifically, we understand this system just only depends on salmon enteritis system, specifically working. And accuracy and precision of system was testing. And then egg chicken, I showed that the biological application. And then we got an R2K value 0.90 and 0.97. And then we got that try the different concentration of bacteria 10/2 and 5. And because we tried the different lower concentration, if you show any response lower concentration, you don't need to try to any higher concentration. And then we got a between 90 and 100%, great result. And phage-based, paper-based system really and really replace antibody with bacteriophage, and then alternative and similar system, and then we construct for this system on the paper-based system. This is like big advantage and major factors. It preferences of over antibody. It can phage can be produced in large quantities easily and cheaply. Only by infected of bacterial solution one can obtain a large number of progeny-phase. So these references, and thank you very much for listening to me. And also special thanks to my advisor, Professor Urtamar, and all of things, and also your committee. Thank you, sir.
Yes, thank you, Dr. İlhan. Dr. İlhan was from Ordu University in Turkey. Nowadays, we are more aware of the importance of the biological studies, and I think your study will be attractive in your field. If anyone wants to ask question, please do not hesitate. All type of questions are welcome. Is there any question to Dr. İlhan? All right, I think there is no question. Could you please make me host again, Dr. İlhan?
Okay, thank you.
Thank you very much.
Yeah.
Bye-bye. And the next presentation is will be done by Gulieva Nermina from Azerbaijan. But I think she's not at the system at the moment, but she sent a video. I can share video with you. I think first I have to play the video, then I will share the screen with you. The video is just 4 minutes long. That's why we start the presentation with the time problem, but we're gonna cover up this problem during the presentation. Yeah. I'm sharing my system screen and could you see the video of the Dr. Narmina? Do you hear me? Dr. İlhan, do you hear me?
Yeah. I see the girl, but I cannot.
Okay, I'm starting the video. It's just 4 minutes long, and we are listening to Dr. Nermina from Azerbaijan. Okay, I'm starting it. And I would like to present him our team works name, reaction of phenylglycine with 2,4-diacetyl, 3-phenyl, 5-hydroxy.
We cannot see video.
Now can you see?
Yeah, we cannot see.
Is synthesis and study of complex functional substitute compounds, including those which are structurally close to nature. Due to their accessibility and functionality, they provide rich synthetic possibilities for constructing on their basis heteroorganic and heterocyclic compounds of various types, including those which possess antimicrobial, antioxidant, and therapeutic action. In this case, polycarbonate substituted
cyclohexanols beta cycloketones have particular importance. Because of one key dioxide fragment that are contained in the structure of mentioned type of compounds, it becomes possible to proceed to emulated bicycle systems, mainly containing 5-membered hydrocycles. Problems of constructing a polycycle system with a large cycle size in their basis remain unexplored or poorly studied, as well as their reaction with aliphatic heterocycle amines and polynuclear reagents. We carried out the reaction of 2,4-diacetyl 3-phenyl 5-hydroxy-5-methylcyclohexanol as a compound containing an asymmetric 1,3-dioxy fragment with phenyl hydrazine. Our products were monosubstitute and disubstitute. Monosubstitute products, our main product, was 56%, and the disubstitute product was 15%. The structure of both substitute products was studied by X-ray structural analysis, showing intermolecular and intramolecular hydrogen bonds. The product has antibacterial features since they have enough nitrogen atoms inside. So this concentrate can be used in production of medicine in future. And so we'll continue to synthesize these products, and we'll carry out a new organic synthesis based on the substance we have obtained. And you can also find more detailed information at the article that we sent you. And thank you for your attention.
And we watched the presentation from Dr. Narmina from Azerbaijan. I think she's not at the system. Okay, then if there's any question, we can take the question, and I will try to make Dr. Narmina be aware of your question. I will try to connect her. Is there any question for Dr. Narmina? I think there is no question. The next presentation will be done by Dr. Adem Tekerek. Dr. Tekerek. I want to be sure if anyone hear me. Dr. İlhan, do you hear me?
Yeah, yeah.
Yes, I heard you.
Could you see the video and heard the voice?
Not yet.
Voice of the Dr. Narmina.
Yeah, I heard that.
Oh, okay, then we don't have a problem with the connection. And
Yes, someone waiting on the door. I think you should click the participants.
yeah, I'm checking. Who's waiting?
Yeah, maybe Adem Hoca waiting. I don't know.
I see 4 participants.
Mm-hmm.
Me, Dr. İlhan, Dr. Karslıoğlu, and the İSTE Hall. No, I can't see anyone that waiting for my invitation.
Okay.
I'm checking if I am the host. I'm not sure. I saw 4 participants and I think I'm not the host. Dr. Ihan, did you give me the host option?
How to do it?
Just right click on your picture
Uh-huh.
and make me the host. Yeah, you now you are the host.
I don't know how to. Let me look. Start.
When you put the cursor on your pictures, you will see a blue.
Yes.
Just
Remove, rename.
just click on it and or just click on my picture on my
Okay, I click.
and make me the host.
I can't find it. Where is it? Okay, let me leave. Oh my goodness. Oh, here, more.
You know, you can make our screen. You can make my video.
Yes, I see your video. I click,
All right.
but there is nothing. Mute, allow, multiple, rename, remove, chat, make us. Oh, I got it. I got it. Okay.
All right. And I
Yeah.
think Dr. Barut has connected to the system.
Can you hear me?
Who is the host? Yes, now I am the host taking Dr. Ilhan, and if Dr. Adam Tekerek is in the system, we can listen to him. We can share his presentation. I think he's not on the system. Dr. Barut, can you hear me?
Yes.
I think we have no connection problems. You sent me 2 video of your presentation. Will you make your presentation live or with the video?
No, I'm presenting now live.
All right.
Okay.
Then you can share your. First of all, you have to open your presentation on your computer.
Okay.
And then to share your screen. You will see an icon below of the page, green one. Yeah, I can see your presentation right now.
Okay.
And you may make a brief, briefly, you may talk about yourself, your university, your colleagues, and
Okay. I'm Urbert. I'm PhD student in Yıldırım Beyazıt University at Department of Metallurgical and Materials Engineering. Today I will talk about fabrication and characterization of graphene reinforced nickel boron and composite coatings produced by liquid deposition. Content of my presentation: introduction, aim of study, hard chrome plating and liquid deposition, experimental methods, bed composition, liquid deposition condition, and characterization of coatings, resultant discussion, microstructure analysis, X-ray diffraction analysis, microhardness of coatings, and wear mechanism, and the final conclusion. Aim of study. In this study, it is aimed to produce nickel boron graphene nanocomposite coatings produced by deposition, which can increase hardness, low cost, is to apply and can be successfully applied, and also as an alternative to hardcore plating, which is used in many engineering fields, but has some disadvantages on human health and environment. Hardcore plating. Hardcore plating consists of depositing chrome layer onto metal components using an electrolytic bath. It has been in use since 1940s, and it's a power process. It's a process that's applied to frictional parts to provide lubricity for protection. Today, hardcore plating method is mostly used in various engineering applications, such as defense industry, gas turbine engine, landing gear, gun barrel, propeller halves, due to their high hardness, outstanding wear and corrosion resistance, low cost, and excellent decoration. But there are two main reasons to replace hardcore plating. The first, problem caused by chromium morphology, and the second, problem caused by hexagon chrome forming during plating. Problem caused by chromium morphology. The micro and macro raw surface of hardcore plating is shown at different magnification in figure. These cracks affect not only the chrome plating but also coated parts. Hardcore plating consists of hardcore plating is often used in applications where the parts are subject to very high wear, and so a thicker chrome layer is required, but excessive thickness results in cracks and larger pore structure on the chrome surface. Problem caused by hexagon chrome forming during plating. During the process, in the plating bed, chromic acid forms in the anode. This chromic acid is a hexagon chromium compound, which is known to be human carcinogen, and the process is quite inefficient, producing large amounts of hydrogen and hydrogen bubbles. Hydrogen and oxygen bubbles. When these bubbles rise to surface, these bubbles burst, throwing fine mist of hexagon chromium into the air. Electrodeposition. Electrodeposition process involves passing an electric current between two electrodes immersed in electrolyte. The positive charge electrode is known as the anode, while the negative charge electrode is the cathode. The electrolyte contains electric charge ions. When an electric potential is applied between the electrodes, these ions migrate towards electrode with the opposite charge. The positive charge ions to cathode and the negative charge ions to anode. Experimental methods. In this study, we used the copper substrate, and copper substrate were grinded with 240, 400, and 600 silicon carbide green paper by using metal grinding device, respectively. After grinding, they were cleaned with acetone, and they were decreased with pure ethanol solution for 1 minute, and cleaned with pure water before the coatings. Then prepared bath solution was treated by ultrasonic homogenization for 1 hour to ensure that nanoparticles did not precipitate in the bath and were homogeneously dispersed. And finally, coating process was carried out. Bath composition and electrodeposition conditions of the coating baths are shown in table. In our study, we use 250 gram per liter nickel sulfate hexahydrate, 1 gram per liter 3-methylamine boron, 40 gram per liter boric acid, and 1 gram per liter graphene, respectively. In the plating bed, nickel sulfate hexahydrate is the main source of nickel ions, and 3-methylamine boron is the main source of boron ions. Boric acid is the buffer of that solution, and it arranges the hydrogen ion concentration in the anode fin. Sodium dodecene sulfate is anionic surfactant. It reduces surface trace and pitting on the surface by specific hydrogen output from the cathode, and it keeps the nanoparticles suspended in the electrolyte. Saccharin reduces the internal stress and prevents the crack formation. It has an effect of the grain refiner. For this study, our work temperature for the coating bed is 55 centigrade degree, and I mixed the coating bed at about 450 RPM during the process. And I use the direct current. I use direct current, pulse current, and pulse reverse current types. And our average current is current type is 3 amperes. 3 ampere square decimeter, and work time is 50 minutes. Characterization of coatings. The surface morphology of electrodeposit nanocomposite coatings were studied by scanning electron microscope. Also, how the grain structure changed under different conditions was examined. The phase and structural analysis were conducted by X-ray diffraction method by using Kakuminiflex X-ray generator. The full width at 5 maximum values of X-ray diffraction were utilized to calculate grain size by using Derbyshire equation. The micro-hardness of the non-composite coatings was calculated using Vickers micro-hardness test device, carrying out load of 50 gram for 10 seconds. At least 10 measurements were applied and average values were taken as references. A resultant discussion, figure 3.1 shows the same image of nickel boron alloy coating and nickel boron graphene nanocomposite coatings, B direct current, C pulse current, and D pierce current, pulse reverse current. According to figures, there was not much change in the morphology of the coatings with the addition of the graphene to nickel boron bed composition. However, serious decrease in grain size was observed. The excited patterns for non-composite coatings shown in figure 3.2. The excited patterns show typical peaks corresponding to 1 1 plane of nickel coatings according to GPDS count number. Especially peak intensity and 1 1 plane in nickel boron alloy coating is higher than the other coating with the addition of graphene. While peak intensity of 1 1 plane decreases, peak intensity of other planes increases, such as graphene oxide 200, nickel 200, 220, and 311 plane. The graphene we add is in the form of graphene oxide. This proves us that new nucleation regions are formed with the addition of graphene. The peak intensity and width are directly related to microstructure. According to Derbyshire formula, the lowest grain size was measured by PRC method. Because with the PRC method, more second phase can be included in the microstructure, and as a result, when the XRD analysis of the coating obtained by PRC method is examined, it is seen that the peak intensity of graphene oxide has increased. Figure shows micro-hardness of coatings. Figure shows the micro-hardness values of nickel boron alloy coating and nanocomposite coatings. Addition of the graphene to electrolyte lead to increasing micro-hardness. The hardness value was measured to approximately 1,124 hardness figures for pulse reverse current type, and lowest hardness value, which is the 965 hardness figures for the nickel boron alloy coating produced by direct current. Weir mechanism. Figure 3.4 shows the Weir mechanism of samples, nickel boron alloy coating and nickel boron graphene nanocomposite coatings, B, DC, PC, and PRC. According to figures, in nickel boron alloy coating, although the predominant weir type was abrasive weir, the emission was seen as the predominant weir type with the addition of nanoparticles and change of the current type. The reason for that, that is the formation of microcracks on the surface due to their high temperature and fatigue that occur during wear, and these cracks progress under the surface and break apart. With the addition of graphene and change of the current type, the amount of abrasion increases. This is because the best surface strength is obtained with the pulse reverse current type. Conclusions: nickel boron graphene nanocomposite protective coating has been synthesized by direct pulse and pulse reverse electrodeposition method. The influence of current types on nanocomposite were investigated. The crystalline size is between 6.23 and 7.24 nanometer. Excited patterns show the peaks belonging to graphene for the nanocomposite coatings, especially peak intensity that belongs to carbon in the coating, which produce pulse reverse current significantly increased. The preferred orientation for nickel boron alloys is nickel 111 plane, but with the addition of graphene, the preferred orientation plane shifted to graphene oxide 222 plane, 200 plane. The reason of that, pulse reverse current enabled the second phases to participate in more microstructure. The maximum hardness value, which is 1,124 hardness meters, is produced with pulse reverse current. Thanks for listening.
Thank you, Dr. Barut. It was a nice presentation and we enjoyed so much. Is there any question for Dr. Barut? If there's a question, we can take it. Okay, I think there is no question. Thank you very much again, Dr. Barut. And you know, the first presentation will be made by Dr. Bülbül. He is working with Professor Dilsiz. I asked Professor Dilsiz if he could make his presentation. She told me that Dr. Bülbül is under quarantine and it's not possible to make a presentation. That's why we have to delete the first presentation. Now I have a video from Dr. Tekerek. Dr. Bard, if you want, you can continue your second presentation, or if you want to rest, I can play the video for.
I can present another. I can present another presentation.
Oh, okay, you want to continue? All right, then
Okay,
you can continue your second presentation.
Yeah, okay. Sorry.
I know everything is okay. Please continue.
Okay.
All right, we can see your presentation.
I will talk about synthesis and characterization of nickel cobalt hexagonal boron-type nanocomposite coatings produced prepared by one-step electrodeposition at different duty cycle. Content of presentation, introduction, aim of study, hard chrome plating, electrodeposition and coating types, experimental methods, best composition and electrodeposition condition, characterization of coatings, resultant discussion, microstructure analysis, X-ray diffraction analysis, microatlas of coatings, MV mechanism, and the final conclusion. This study is the continuation of the previous study. So I am directly passed to current types. And current types, electrodeposition can be applied under direct current and pulse current. Direct current is unidirectional, so the charge flow is always in the same direction and constant in time. In pulse current, the potential or current is alternated swiftly between two different values. This results in series of pulses of equal amplitude, duration, and polarity, separated by zero current. Each pulse consists of on time, during which potential is applied, and off time, during which zero current is applied. It is possible to control deposited film composition and thickness in atomic order by regulating the pulse amplitude and width. Pulse current favor the orientation of nuclei and increase the number of grain per unit area, resulting in finer grained deposits with better properties than conventional coatings. Interpolating negatively charged layer is formed around the cathode as the process continues. When using the direct current, this layer charged to the finer thickness and obstruct the ions from reaching the part. In pulse current, the output is periodically turned off to cause this layer discharge. This allows easier passage of the ions through the layer and onto the part. High current density areas in the bed become more depleted of the ions than low current density areas. During the off time, ions migrate to depleted areas in the bed. When pulse on time occurs, more evenly distributed ions are available for decomposition onto the part. While pulse current significantly increases the limiting current density, limiting current density by replacing metal ions in the diffusion layer only during the off time. Experimental methods in the study, we used the copper substrate and they were organized with 240 and 400 and 600 6-chloride grade paper by using metal grinding device respectively. After grinding, they were cleaned with acetone and then were decreased with the protein solution for 1 minute and cleaned with pure water before coatings. Then prepared bed solution was stirred by processing later for 1 hour to ensure that the nanoparticles did not precipitate in the bed and were homogeneously dispersed, and finally coating process was carried out. And bed composition and electrodeposition condition of the bed coating are shown in the figures table. In our study, we used the 250 gram per liter nickel sulfate, 50 gram per liter cobalt sulfate, heptahydrate, and 40 gram per liter boric acid, and also 0.5, 1, 2, and 5 gram per liter 5 gram per liter hexagonal boron nitride nanocomposite. In depleting bed, nickel sulfate hexahydrate is the main source of nickel ion. Cobalt sulfate heptahydrate is the main source of cobalt ion. Boric acid is the pH buffer of the best solution, and it arranges the hydrogen in concentration in the cathode pin. And sodium sulfate is anionic surfactant. It reduces the surface trace and pitting on the surface by facilitating hydrogen output from the cathode. It keeps nanoparticles suspended in the electrolyte. Saccharin reduces internal stress and prevents crack formation. It has effect of the grain fire. For the study, our working temperature is 55 centigrade degree, and coating bed was mixed at about 250 RPM during the process. And the current types for the study: direct current and pulse current. Average current density is 3 ampere over decimeter square decimeter. Characterization of coatings. The surface morphologies of electrodepositional composite coatings were studied by scanning electron microscope. Also, how the grain structure changed under the freezing conditions was examined. The present structural analyses were conducted by XRD, that means X-ray diffraction method, by using the Miniflex X-ray generator. Full fits at high maximum values of X-ray diffractions were utilized to calculate the grain size by using the Derbyshire equation. The micro-hardness of the non-composite coatings was calculated by using Vickers micro test device carrying out load of 50 grams for 10 seconds. At least 10 measurements were applied, and average values were taken as references. Figure 3.1 shows the same SCM image of nickel cobalt hexagonal nanocomposite coatings produced by different duty cycle. A, nickel cobalt; B, 30 duty cycle; C, 50 duty cycle; D, 70 duty cycle; and finally E, 90 duty cycle. According to figures, as the number of duty cycle increases, the porosities were formed in the microstructure, especially at the 90 percent duty cycle. Extremely porous structure has been obtained. XRD patterns for nickel cobalt and non-composite coatings is shown in figure 3.2. XRD patterns show the typical peaks for the point nickel cobalt 111 and nickel cobalt 200 plane of nickel coatings. It is known that the 111 plane has higher atomic density when compared to other planes. Detailed analysis of the XRD patterns of nickel cobalt alloy and nickel cobalt hexagonal boron and non-composite coatings is shown in figure 3.3. And according to Derbyshire formula, the lowest grain size was measured in 32 cycle. Furthermore, in the highest grain size was measured 92 cycle. According to the tight analysis, the largest full width halt maximum and peak intensity volume were obtained at 90 cycle. This analysis proves that the smallest grain boundary is achieved at 90 cycle. Micro-hardness of coatings. Addition of the hexagonal boron to electrode lead to increase in micro hardness, but after a certain point, micro hardness values decrease because of addition in resulting agglomeration. A figure shows the micro hardness values of nickel boron coating and nanocomposite coatings. The maximum hardness is obtained with the 30% to cycle, and lowest micro-hardness was obtained with the nickel cobalt alloy coating produced by direct current. Weir mechanism. Figure shows the SCM image of Weir mechanism. Nickel cobalt alloy coating DC, nickel cobalt hexagonal boron non-composite coatings produced with 30, 50, and 90% duty cycle. Dominant abrasive marks are seen in the nickel cobalt alloy coating. As T-on increased, the lamination coatings increased due to high temperature and fatigue. The lamination is in the form of microcracks on the surface, advancing under the surface and far separation. The low delamination occurred at 30% duty cycle, and this is this is seen in the EDS map analysis. The most elimination occurred at 90% to the cycle. This proves that it is at 90% to the cycle with the highest oxidation and is seen in the EDS analysis. At the same time, abrasive marks were formed at 90% to the cycle. Conclusions: nickel cobalt alloy has been synthesized by direct current, and nickel cobalt hexagonal monocomposite coatings have been synthesized by pulse current with the different tooth cycle. Effects of tooth cycle on nanocomposites were investigated. Crystalline size is between 13.26 and 15.44 nanometer. Preferred orientation for nanocomposites is nickel cobalt 111 and 200 plane. With the change of the tooth cycle, no new orientation plane was formed. Study patterns don't show the peaks belonging to hexagonal boron nitride for the nanocomposite coatings because of the low amount of dispersed hexagonal boron nitride reinforced added electrolyte. The maximum hardness value, which is 458 hardness vickers, is produced to 32 cycle. Thank you for everything. Thanks for listening.
Thank you, Dr. Barut. Your second presentation is also very joyful for us. Is there any question for Dr. Barut? If you have any question, if you're curious about something about the presentation, I think there's no question. Okay, thank you very much, Dr. Barut. Today we have 6 presentation, and as I said before, the first presenter, Dr. Bülbül, couldn't make his presentation, and I asked for Dr. Tekerek. He sent me a video yesterday, and I will play that video, but I'm not sure about the duration of the video. I'm sharing my screen to, let me see, where is the video? Just let me a minute to find it. Adem Tekerek is from Gazi University. The name of his presentation, Human Recognition Based on Artificial Neural Network by Gained Pattern. Yeah, okay, I found it. Yeah, we are listening to the video.
Hello, my name is Adem Tekerek. I am working at Gazi University as PhD lecturer. In this presentation, I will present you my work about human recognition based on artificial neural network by gate pattern. The content of my study is aim of study, human recognition with gate pattern, used datasets, developed artificial neural network model, experimental results of study, and the conclusion. The aim of study is it is proposed to estimate the recognition of individual or human by gate pattern of 30 different people mentioned in datasets. The dataset produced with the framework of an experimental study using smartphones or human activity recognition is used with the potential application in assistive life technologies. Activity recognition aims to define the actions of a person by collecting data about himself and his surroundings. Activity recognition can be performed by processing information collected from sensors such as accelerometers. Nowadays, the sensors found in some smartphones are embedded, and the data collected from these sensors classifies some physical activities like walking, climbing, staring, etc. by processing body signals with a series of machine learning algorithms. Human recognition with gait pattern. Biometric data such as fingerprint, palm, muscular structure, or gait pattern that humans have had since their birth are almost impossible to change. Biometrics is a collection of measures of human psychology and behavior. Gait pattern is personal information and it should be kept confidential in order to ensure personal data and privacy. Use dataset in the study. Human physical activity recognition dataset is used. The dataset is produced by using a Samsung Galaxy S2 smartphones. Only one gait walking activity data is selected and there are 1,722 walking raw data, which belongs to 230 different volunteers. Human recognition is implemented individually by using the walking data in datasets. The experimental of the study. Proposed artificial neural network model has 561 input variables, 2 hidden layers with 20 neuron and 1 input and 1 output layer. Model structure is multi-layer. According to the artificial neural network model evaluation, training regression rate is 1.99. Validation regression rate is 0.96. Text and test regression rate is 0.96 and error rate is 6.04. The conclusion of the study. In this study, it has been proven that personality or individuality prediction can be made by using gait pattern of people. The dataset used in the study was generated by smartphones. Mobile applications such as step counter or similar applications on smartphones collects personal data and it leads to the disclosure of personal information security and personal privacy. So the gait pattern of human can be defined as biometric data, and because of the importance of personal information security, it is urgent that gait pattern should be secured. The model predicting the human by using gait pattern of human with artificial neural network method was suggested in the study. High accuracy estimates are conducted with suggested artificial neural network model. Therefore, its presented artificial neural network model is suggested in terms of performance. This study proposed that biometric data security should be provided to ensure personal information security and privacy. Misuse of gait pattern, which is important biometric personal data, may threaten the personal information security. In particular, it is necessary to ensure the security of gait pattern collected by smartphones. Thank you for listening.
And we listened to presentation of the Dr. Tekerek. I don't know how to do this, but if there's a question, I will try to let him know about it. Is there any question? All right. Today we had 6 presentations. 2 of them were done by video. 3 of the presentations was live by Dr. İlhan and Dr. Barut. Dr. Barut talked about the surface covering, and Dr. İlhan was give us beneficial information about biology and blocking the bacteria. First presentation couldn't be made because of the health problems of the Dr. Bülbül. All the presentations are done except Dr. Bülbül. So I'm closing the It's the afternoon session. If anyone want to add something, or if anyone has idea about the presentation, we want to hear. All right. We will also see the full text of the presentations, and we will have chance to reach the studies in details later. If no one wants to
Yeah, Dr. Çetin, Cenk Kumroğlu is coming.
who is coming?
Sorry, can you hear me?
Yes, yes.
Yeah, Kumroğlu, last. Okay.
Kumruoğlu in my list, but I think my Excel list is not up to date.
Yeah, it is. Yeah. In the last version, last
right.
version of the exam, it has last version has his name.
Yeah,
Sorry.
I understand. We have 7 presentation.
Okay.
All right. It's coming into. Is it connecting to the Zoom or?
Yeah,
All right.
yeah, I told
We're waiting.
him he's coming.
All right. I couldn't update my files because I have to admit I'm also under quarantine because of COVID-19.
Yeah.
Yesterday they had a message from the health ministry. They told me I'm forbidden to go out for 14 days, and I will stay
14 days.
for 14 days. Yes,
Yeah.
I'm restricted. But I think
It
it's
looked like very long time, 14 days.
yeah. I will
Yesterday it started. Okay.
They told me that I have a connection with a COVID positive person.
Okay, I see.
They take samples from me yesterday, but I think I'm negative because they didn't return me, and they didn't inform me. If you are positive, they turn and inform you in 2 or 3 hours. Immediately, they visit you and make some tests and give you medicine.
Real.
Yeah, but I'm lucky I'm COVID negative, I think, because no one has informed me anything, but I have to stay in the home 2 weeks. There's no way out.
I see.
And what was the name of the last participants?
Levent Cenk Kumruoğlu.
Levent Cenk Kumruoğlu. Now he is connecting. I let him in the room. Dr. Kumruoğlu, welcome to our presentations.
Hello.
Sorry that my list is not up to date. I heard that you are the last one in the schedule.
Yeah. Actually, I was waiting for my QE. So I think we are earlier than 1 hour, right? 1 hour.
Yeah, we have enough time because one of the participants couldn't make his presentation, and
All right.
the presentation was by video, and duration of the video are very short because of the size limitation.
Okay.
But I have no information about you. Could you make a brief introduction of yourself?
Of course, I like it. I like it, Professor.
You can start your presentation.
Yeah.
We are listening to you.
If you give me chance, I can talk until morning.
Yeah, share until morning. You.
I'm kidding, right?
20 minutes is enough, I think.
Okay.
Maybe later in a different meeting we can talk more. But of course, if your topic is interesting,
Thank you very much. It's case study.
I don't have any idea about your topic.
Oh,
Could you please give us a small information and introduction and start your presentation, please? Okay, we are listening you.
okay. Do I need to share my screen or just we are talking about the face-to-face?
Yes. First, open your presentation on your computer.
Yes, it's already open.
Then under the screen, there is a green
Yeah, I know.
share screen. Click on it. And it will ask you which of the open window you want to share from your computer, and you're choosing. I can see your presentation right now.
Yeah.
Then make it full screen and go.
Okay, thank you very much.
You should go to presentation page to make it full screen. Now it's okay. It's all right. It's working. Okay, we are listening you.
Does everybody see my screen clearly?
Yeah, it's clear.
Okay. Thank you very much, dear chair. My presentation will be about heat treatment. Heat treatment is very actually ancient technique we used from before Chris 1000, but at the moment nowadays it's still used in many companies, especially in heat treatment companies, because we know this still is a huge amount of product in our life. So we can't leave the steel, even if we study nanotechnology and so on. So I prefer to study generally case studies, especially academic and industry cooperations. This is also this kind of work. The purpose of the work is to increase the extrusion die wear capacity, wear resistance capacity. So we applied some well-known steels, ISI 86 and 20 and 52 100 steels, well-known and actually low alloyed and high alloyed chromium steels. This is low carbon, this is high carbon. We made extrusion die with these materials. Then we applied traditional austeniting and cooling process. Then we performed some impact energy testing, wear testing, and macroscopy studies, so on. Let me introduce the heat treatment procedure. This is well-known graphic, but I would like to add some extra information here. Temperature, this is room temperature, this is temperature. The temperature increase in the furnace, then stabilize in this region. We call austenization temperature. We just performed this kind of 8620 steel because the low carbon content. I add the carbon content here is 0.20, very low. We can't harden this kind of steel by quenching because of the low carbon content. And then low carbon potential, because of the low carbon potential, we performed carburization process, lowering the temperature 70 degrees to 150. And we kept in this temperature the extrusion dies during the 120 minutes. Then rapid cooling takes place in here. We choose the quenching media as oil, industrial quenching oils, and hold the samples for 45 minutes. What we do here, we transform the structure of the steel from austenite to tetragonal, body-centered tetragonal structure. We change phases. Then we hold 45 minutes at 80 Celsius degree. Then applied sub-zero treatment. Sub-zero treatment means cooling the samples up to minus 120 or more cooler temperatures. Then, of course, we need to tempering process, and it's probably above 100 to 200 during, let's say, 550 minutes. I put a small picture here. It shows the transformation from austenite to ferrite. But when the rapid cooling, it turns the martensite. Okay. We have microstructure. As I said before, we had two kind of steel. One is low carbon, the other one is high carbon. You see the microstructures, heat treated is so the bigger grain size. Then hardened, you see the Martens plates. And after sub-zero treatment and tempering procedure. Similarly, we may see the other microstructure here. The air on A shows the retained austenite. It means non-transformed austenite after heat treatment. We can reduce the austenite size, non-transformed austenite, retained austenite down to 600%. And similar digits are here, as you can see. In the measurement taken from the surface of the samples, a residual austenite of 15 and 25% was encountered. Residual austenite transform Martens structure in the quenched steel after austenite according to cryogenic. We also call the cryogenic treatment is equal to sub-zero. They are totally same. The amount of retained austenite obtained in the 52-100 steel is higher than 86-20 steel. We have also another proof here showing the hardness. This kind of hardness profile shows the from surface, the cross-section of the samples from surface to core side. You see untreated one, the hardness very low, and hardened one, approximately 800 Vickers hardness, and reducing from distance the surface to core. Similar graphs shown in another materials. The B shows chromium steel. The A shows low carbon steel. The hardness of cryogenic treatment after cryogenic treatment, the hardness increased by 4.5%. And we achieved 6% reduction in hardness. And we achieved 0.8 millimeter stable hardness layer here. So what's different? Different come from the existing of manganese. The reason for the high hardness of the chromium steel is due to the mangan in its content. The effect of the applied cryogenic process on hardness is decreased after that. Another study performed for wear test. Sorry, little picture I forgot here. Showing the wear scar in here, A, B, C, and D. You see untreated samples showing chromium steel, untreated and hardened and sub-zero treated, then tempered. We can see the table inside the screen. Loss of sample grams, milligrams, and friction coefficients. Sub-zero treatment reduced the friction coefficients from 0.6 to 0.2 approximately. We also gained same values from chromium steels. And after tempering, we get a little slightly more friction coefficients and loss of wear loss after tempering process. Let me continue. Of course, we try to improve the structure of the samples by using SEM, untreated, hardened, sub-zero treatment, and tempered. Hardness value were gradually increased on non-treated and heat-treated samples in seconds for impact testing. And however, the material show a more brittle fracture because of the hardening process. Non-treated steel samples had a lower impact absorption rate, of course. The hardness of toughness values of the heat-treated sample increased and absorbed impact energy increased as well. Heat-treated samples have been shown to show more ductile refraction. The notch impact strength value of the have been brought from level of the 250 joule to 20 joule. The same analysis performed, of course, with the impact testing analysis proved that. Similarly, 200 chromium steel shows similar behavior, also ductile refraction without processing, but after processing, it's turned into brittle refraction. Cryogenic treatment was less pronounced in the last sample and brittle fracture occurred. The cryogenic process and tempered sample showed no transition region and brittle fracture was observed. Let's put it in a nutshell conclusion. The deep cryogenic treatment up to minus 120 Celsius of quenched temperate ASII 8620 and 52100 steels improve their properties, hardness, strength, and microstructure. The amount of retained austenite is reduced by 75% after the sub-zero process and after the carbonization, of course. It's observed that the increase in the amount of the residual austenite adversely affect the hardness. the maximum reduction in the amount of residual hazardness was observed in chromium steel. Since high amount of retained arsenic in the carbonized case decreased the wear resistance and also fatigue limit of machine parts because we applied the extrusion die. Not only wear properties are important, but also we concentrate on the fatigue. They are work cooperatively. Consequently, the carbon contents also very important. Lower than 0.7 carbon and quenching temperature must be under martensite finish temperature. So increasing the carbon content make the transformation easier. The steel extrusion mold samples was subject to wear test at distance 500 meters under load of 30 Newton, and the hardening process was found to increase wear resistance. This part of the study is very important because we cannot increase the traditional or alloy steel without surface coating. We tried to increase the wear resistance without increasing hardening and without surface coating. We just used the sub-zero effect and we increased wear resistance. Actually, I think my presentation is finished here. If you have any question, I would like to answer. I will do my best.
Right, Dr. Kumroğlu. We are appreciated with your presentation, your informative presentation. And if anyone has any question.
May I?
Yes, sir.
Yes.
Hello, thank you very much, dear Chair. Thank you very much, Levent, for this good presentation and this Chair. My question is about cryogenic treatment and cryogenic treatment and sub-zero treatment. I mean that, what is the difference between them? Secondly, can you tell us what is the purpose of the cryogenic treatment for the especially iron-based materials? The other question is about how did you determine the parameters such as temperature, such as cooling rate? How did you determine? And lastly, did you observe different things in cryogenic after cryogenic treatment? I mean that, for example, did you check after 1 year or more later your samples? To your samples? I have 5 questions, Levent.
No. I appreciate. They are really very perfect questions. You hit the point, Professor Ateş. As I remember, I would love to answer your questions. Yes, the observation of long term is very important because, as you know, the transformation is not stable as a thermodynamically, and structure may naturally wants to turn the original phase. So I'm gonna write a note and I will do this advice. Actually, I have no idea about 1 year, 2 years, or 3 years later the amount of austenite.
For example, Levent, after 1 year later checking, I observed 10% increase in mechanical properties of my samples.
10%.
For example, Did you observe?
No, no, no, no. We just finished and controlled, but I have samples, and according to your advice, I will do. I will do. I didn't know that. Thank you very much. And another question.
How did you determine your parameter?
Parameter, yeah. Actually, we used liquid nitrogen, and the capability of the liquid nitrogen is 120 minus Celsius. Actually, this restricted us, and according to our experiment, we know the austenitic temperature and quenching in oil media is more produce more sound dyes. Otherwise, if we use another materials, we may broke it, and transformation make the form and micro cracks occur on the surface of the materials. Actually, we use our experiment during the study. Also, we want to increase the carbon content of low alloy 86-20% steel. We increase the surface carbon content up to 0.57. So the duration also we weighed and measured all the time. The surface, when we stop the endogas process, when we reach 0.7 to increase the wear hardness, wear resistance and hardness. The other parameters, tempering is also, we experienced several tempering process, but if we increase the temperature, tempering temperature, the materials goes to softening. If we apply a low temperature, less than 120, in this case, it makes steel brittle. So I can say we determined all parameters by try and error technique.
Thank you. Thank you.
Professor Ateş, your first question, what's the difference between a cryogenic process and sub-zero?
Yeah,
That's really good question. I think we material scientists and metallurgists use sub-zero, but the other disciplines such as food engineer, chemical engineer, petroleum and natural gas engineer use cryogenic process. For example, if you you are very experienced about powder metallurgy, we start with grinding materials using powder metallurgy. But if you want to crush a hair, for example, hair, what can we do? We cool down and we make it brittle, then crush. That's why they call, for example, scientists who studying biomaterials like a hair, they cool and make a brittle hair, then crush. They say cryogenic process. I can say
very interesting example. But as well as I learned from my teacher, he said to me about 196 degrees Celsius called cryogenic, whereas the other sub-zero is about until zero, about 80 degrees Celsius. Thank you very much, dear Levent. Thank you very much, dear Chair.
Thank you very much, Professor Ateş.
You're welcome. In the last speech, I learned that the cryogenic temperature is the temperature under 77 Kelvin. That's the temperature of the nitrogen melting temperature. Okay, today we had 7 presentations, and the first, we couldn't achieve the first presentation because of the health problems of the presenter. And it was good, and all the ideas are shared between the scientists. It was beneficial, and if anyone wants to talk about today's presentations, we want to listen. And if everybody is okay, I want to say goodbye to all of you till we come together in another organization. And I want to thank all of you. I was a little bit late because of the connection problems, and I have to apologize from everyone again. And thank you to all. Hope to see you again in a different congress or symposium. Thank you very much. Bye-bye.
Thank you very much, Chairman.